Hello guys, and welcome back to the Universal Physics, to a new series about fundamental particles. Physics is a study of how everything in the universe interacts with each other. But at its very core, physicists need to know how matter interacts with each other, and the quest for the most fundamental particles is essential. If you ask most people, they'll say that protons, neutrons, and electrons are the most fundamental particles in the universe, but that is totally incorrect. The quest for the most fundamental particle is much more complex and has been in the works for centuries, and is yet still not over. Most of this work has boiled down to the most basic model of all. This, my friends, is the Standard Model. Now, what you're seeing right here is called the Standard Model. It's the most complete model of all the fundamental particles in the universe, and it's the one most widely accepted by scientists. Every single particle in this model has been experimentally proven, and it's the most accurate one we have. Now, the Standard Model has a lot of different particles, and I'm not going to be able to explain them all in one video. That's why I'm going to create a series of 5 videos, this being the first one, where I'll explain all the particles in the Standard Model. Now for today, I'm going to help you understand the Standard Model and what type of particles are where, as well as some flaws of the Standard Model. So, without further ado, let's get started. Okay, so before we dive into the matter particles, which are the first type of particles that I'm going to talk about in the Standard Model, you have to understand a characteristic that all these particles have called generations. Now, when you look at all the matter particles in the Standard Model, you notice that there are 3 rows, and scientists call each one of the row their own generation. So, for example, this row is the first generation, this one is the second generation, and so on. And basically, the idea of each generation is that each particle in the generation, like let's take the up quark for example, the second and third generation particles that are in the same row as the up quark, they're basically copies of the up quark, but just heavier and less stable. Now, for example, if you look here, you notice that the spin and the charge and the spin are the same, so they're the same particle. They maintain the same properties. But when you look at the mass changes, and because their mass gets heavier, because they're getting heavier, they also become less stable. And it's the same thing for all the different particles in the Standard Model. When you look here, all of them are maintained, but as you go on into the generations, they get heavier. Now, this is really important because most of the particles you're going to be dealing with are here. These are the particles that make up most of the matter in the universe. Now, the other 8 particles, they're still important, and you'll see them come up here and there, but they're not as common, and it's really important that you understand this. Now, no one knows why there's 3 generations of the same particle. That's one of the biggest unknown mysteries of physics, but hopefully someone will find that out. So now I'm going to really briefly I'm going to really briefly explain some of the particles and some of the matter particles in the Standard Model. Now, I'm going to explain the first generation particles, because the second and third generation, they're just basically copies of it, and they're not as common. So the up and down quark, those are the particles that make up protons and neutrons. So protons and neutrons. Then you have the electron, which I'm sure you all of you guys know. It orbits the nucleus of the atom. Now, this is not a correct picture, but this is the electron here. So the electron. And then you have the electron neutrino, the neutrino. Basically, the neutrino, it's usually some type of leftover from a particle decay or something, like if a proton decays into a neutron or something like that. Sometimes in stuff like that, electron neutrinos are left over, but they don't make up anything in the atom. Now moving on to force-gating particles. Now the force-gating particles are all the particles right here. They're the gluon, the photon, the Z boson, and the W boson. And basically, these four particles represent three of the four fundamental forces. They represent three of the four fundamental forces, and if you don't know, those are magnetism, you have the weak nuclear force, and then nuclear force, and then the strong nuclear force, and then you have gravity. Now gravity, it's an exceptional force because it's covered by Einstein's general theory of relativity. But here you have these particles represent electromagnetism, the weak nuclear force, and the strong nuclear force. Now the gluon, that is the particle that represents the strong nuclear force, which binds particles in the proton and neutron. Then once you go down to the photon, I'm sure all of you guys are familiar with photon. It makes up light, and it's the particle that transmits electromagnetism. So one of the fundamental forces. And then you have the Z boson and the W boson. Now they explain the weak nuclear force, which is a little bit more complex, and it's important when you're talking about proton decays and stuff like that. But it's a little bit more complex. And yeah, that's pretty much it for the force-carrying particles. Now the last particle I haven't covered is this particle, and it's called the Higgs boson. Now the Higgs boson, it's by far the most complex particle in the Standard Model. And so this particle by itself deserves a video of its own. But I'm going to give you a 10-second summary. Basically, the Higgs boson, it gives mass to all the particles in the Standard Model by interacting with it. So the particles interact with the Higgs boson and they get their mass, except for a couple, but they get their mass from the Higgs boson. And yeah, that's all the basics there are to the Standard Model. Now to dive into all these particles, I'm going to have a series of 5 videos, this being the first one, where I'm going to explain a specific section of the Standard Model. We're going to have a video about quarks, one about leptons, which are the two types of matter particles. We're going to have the force-carrying particles, aka the 4 fundamental forces, and then we're going to have a video dedicated to the Higgs boson. Now, if you like my videos, click here to subscribe to my channel. If you want to see more videos like this, click up right here or here to get access to some of my other videos. That's it for today. I'm Zaid, and I'll see you next time on The Universe with Physics.